Kia ora, good morning. My name is Kate Parker and I work at Scion, where I am the portfolio leader of the bioproducts and packaging team. Today I'm going to present to you on bioproducts for the sustainable future. Today I'm going to present on bioproducts for a sustainable future. So my presentation is split into two different sections. I'll start by setting the scene, giving a global perspective on why we need a sustainable future and what it means. And then I'll move into specific examples of sustainable bioproducts that we have developed at Scion through our own R&D and through partnerships that we have with other collaborators. So we are facing some major challenges. The human population is living beyond its means. Earth Overshoot Day, many of you probably already know, is the day each year that we start to consume more resources that can be produced by the Earth in a year. Over the last 40 years, this day has got earlier and earlier in the year as our rate of consumption increases. And the only exception in that was last year, when we gained a couple of weeks back as a result of the major pandemic, which slowed our consumption. And this was particularly in fuel consumption. Unfortunately, this year, Earth Overshoot Day set a new record when it fell on July 29th. So we're already well past World Overshoot Day for this year, and as a result, by the end of the year, we would have consumed as if we had 1.7 Earths. We're living beyond our means, beyond our planetary boundaries as well in a number of areas. And as you can see here in the figure on the right-hand side, we have a number of issues that are of concern. Now, I won't talk to all of them, but the example I'll talk about first is genetic diversity, which is highlighted here in red, indicating that it is high risk, and we know that this as more and more species become extinct. Another one I'll talk about is climate change. Climate change, we know, is a major issue, not yet in red, but shown here in yellow to highlight it as an increasing risk. So to counter climate change, we have the Paris Agreement, which has this inspirational goal of keeping global warming below 1.5 degrees Celsius. However, to achieve this, it's recently reported that to achieve this goal, then significant levels of carbon must stay in the ground. For example, 58% of the economically viable oil reserves must remain in the ground, 59% of gas reserves, and 89% of the global coal reserves must all stay in the ground. So to counter this, we're going to need an alternative renewable source of carbon. On this slide, I've shown here three sources of renewable or sustainable carbon. Firstly, we have plants, trees and other biomasses that are a major source of carbon. Secondly, we need to capture carbon from the atmosphere, this being done in the form of carbon dioxide or methane. And thirdly, we need to look at Technosphere, recycling of carbon. So that's the man-made, recycling of carbon that we can do. So what can we do, and how does this affect us? Well, we have trees. Well, most people think of trees. They think trees to timber. Then they use the timber for buildings, they use the timber for fence posts, whatever. Some people may also think of timber turning into paper and board. So these trees may be used for packaging or for books, if people are still reading books. But there's many other resources that we can get from trees. Traditionally thought of as waste products, we think of these as resources. And I've listed a number of these here. As you can see on the image on the right-hand side, starting from the outside of the tree, we have bark. Bark traditionally has been left in the forest and not been used. We get sawdust from cutting the timber. This is a major resource for sawmills and such like, which is becoming a problem for them. And we have wood fibres. Looking deeper into the wood, we can think of the polymers that the wood is made up of. And here I'm talking about the cellulose and the lignins that hold the tree together. Finally, if we break apart those polymers, we can look at other chemicals that are derived from the tree. Not only the extractives that come out, but the monomers that coming from the cellulose or lignin, such as the sugars and the other monomers. At Scion, we look at all these resources and how they can be used to make new products. And now I'm going to talk through a number of case studies of bioproducts that we have developed at Scion using these resources. So starting at the top of the list, we will talk about bark. Now you've already heard Stefan's presentation earlier this morning when he described the bark biorefinery project. He talked about a number of different chemicals and materials that can be extracted or produced from radiator pine bark. And here I'm going to take that a little bit further and talk about a couple of the early products that they have got out of this project. And giving a very simple example of the work that they did to start with is they took the radiator pine bark and they extracted the tannin. So here you have two materials. You have the pure tannin that you've extracted from the bark as well as the tannin extracted bark. So for the tanning process we all know has been around many years, but not all lignin is the same. And here they've used radiator pine, not all tannin is the same. Here they've used radiator pine tannin to treat leather, as you can see from the images of the right hand side of the slide. This went very well and they got a very nice product, as you can see there, and they got different colours as well. The remaining extracted bark was then compressed into these bark briquettes that are shown on the bottom left hand side of the slide. And when they tested these, they showed they had excellent calorific value as well as low ash value, making them ideal for burning and a great energy source. And as a result, you've got these two products coming out of the bark and you've got no waste left over as all the bark has been consumed. Okay, down on the bottom left-hand side of this slide, we have an example by Jasmax, which is an architectural firm. So Te Hau Ora symbolises the connection between the physical and the intangible. Here they have taken, on the bottom left-hand side, they've taken some Purple Heart wood from the Queen's Wharf project up in Auckland. When they dismantled the wharf, they took the wood from it, they made it into a powder and added it into their 3D printing filament. They hand dyed the filament and they were able to create this form, a taonga or treasure, that is unique to Jasmax. So now moving into fibre. This is another product that Scion has been working on for a very long time, and some of you have probably heard of this product before, which is called Wood Force. It is very similar to wood plastic composites, which incorporate wood flour into plastics, and a material that is used worldwide for a lot of decking material. The unique property here in Wood Force is that we're using wood fibre instead of wood flour or sawdust. The fibres can be added in a loading up to 60 to 70%, and the fibres give you a reinforcing property, making the products much stronger than if they just had the flour in them. And this makes them a viable alternative to glass fibre reinforced plastics, but with other advantages. For example, when you use the wood reinforced plastics, they're much lighter than the glass reinforced plastics, making them much more ideal material for high value applications such as automotive, where lightweighting is key. And the image up there on the right hand side of the slide gives an example of a dashboard that has been made for a car out of this wood fibre reinforced plastic. A further sustainability advantage of this material of Wood Force is that it can be recycled. If you try to recycle glass reinforced plastics, once the material passes down the extruder, the glass is all broken up and you're losing your strength properties that come from the fibres that are put in there. With the wood fibre, it is much more flexible and not brittle like glass, so you can put it down through the extruder again and it's able to retain its performance, and is able to be re-extruded up to 5 times before the fibres start to deteriorate. I'll just talk briefly around the image there on the bottom left-hand side of the slide. This is the real secret of Wood Force and where our R&D came in. So if for any of you know that have tried to put wood fibre down the extruder, it is really light and it's fluffy and it's really hard to feed into extruder. So what we have done is developed this technology to make these Wood Force dice, which is the second beaker there shown, which appears to have much smaller amount of wood fibre in it, but actually weight to weight they're exactly the same between the two beakers. The Wood Force dice are special because once you feed them into the extruder they feed very well, but the fibres are able to release from each other and evenly disperse throughout your plastic material. Alright, still talking about fibre, I've just put this slide in to to remind you or reassure you that Scion still does plenty of research in both paper and board materials, although this is not really an area I'm going to talk about today. Paper and board has been our bread and butter for many, many years, and we have lots of expertise and capability in this area. And as you can see from the slide, and if you didn't already know, we have covered it all from the pulping of the wood all the way through to bleaching, making and testing of paper, as well as board performance, and then extending that into complete box performance under a range of different conditions that they may encounter in the supply chain. We have also expertise beyond this in food contact compliance and other areas that make these packaging materials relevant for our New Zealand exporters. But I am going to talk about another area of fibre packaging that we are growing at Scion, and this is moulded fibre. Now, moulded fibre is traditionally your egg tray type materials, which you can see in the picture there on the right. These have been considered low cost and low quality for many years and largely ignored. However, bans on single-use plastic products, as well as global packaging commitments around all packaging materials needing to be 100% recyclable, reusable or compostable by 2025, have resulted in moulded fibre being a real focus area for packaging the whole world over. With new technology coming along, moulded fibre is now a huge growth area, and as the technology improves, they're developing new equipment such as moulded fibre thermoformers. So now this product is starting to become a premium product and is being used now by the likes of Apple for packaging of their iPhones. Another area where moulded fibre is getting a lot of publicity is in by many alcohol companies forming these fibre bottles, which is a new sustainable thing that's been used for promoting a lot of alcohol products. And that can be seen in the image on the left-hand side of the slide. I will say yes, although they are largely fibre-based, they usually do have a plastic bladder inside or some other plastic lining of some description to ensure that they are waterproof. So although better in terms of higher fibre content, they still have plastic as part of them. This again is a newer area of research for us, and we are developing in this area over the next couple of years. We've just purchased a new pilot scale thermoformer, which is on its way to us from Germany, and once that arrives, hopefully by Christmas, we're about to start scaling up of some of the lab work that we've been working on over the last couple of years. All right, now I'll move on to what I've described as polymers from wood, and specifically this first example I'll talk about is lignin. Okay, we've been using lignin as a low-cost, high-carbon ingredient to make nanofibres. We started this work at lab scale, and we've scaled it up through a collaboration with Revolution Fibres. Now, Revolution Fibres recently changed their name to Nanolayer, who is indicated on this slide. Nanolayer is a nanofibre production company with proprietary electrospinning technology. In collaboration with them, lignin can be electrospun to randomly orientated mats, as shown in the picture at the bottom there. Now, this is a SEM image, so you can see the detail in the fibres. The fibres are super fine. They are 500 times smaller than human hair, and the image there in the middle slide shows that. So the human hair being the thick fibre you can see in that picture, in that image, and then the electrospun nanofibre crossing it. Lignin has been used to make these nanofibre mats, as shown in the top picture. So this is a commercial trial that was done at Nanolayer in their facility up in Auckland. You take these mats, which are then carbonised or cooked at very high temperatures as a stabilisation step, and it also increases their conductivity. From that, we have a high conductive product coming out and looking at different applications where these can be used, such as energy storage, coatings, air filters and other composite materials. Another product that we've been using lignin for is bioadhesives, or basically just a glue for wood. And we have developed these as a replacement for urea formaldehyde resins. They're ideal for plywood, also for MDF, medium density fibreboard, as well as particle board. And this product is called Ligate. So as I said, Ligate's main ingredient is lignin, There are also some proteins for cross-linking and a couple of other minor renewable ingredients. It is designed for interior applications, and as it is formaldehyde-free, we know that there's no formaldehyde emissions from these products, making them ideal for in homes. In fact, Ligate has been shown to be a scavenger of formaldehyde, leading to emission levels lower than natural wood for these products. This has been developed as a drop-in technology, so the resin can be made on existing facilities using existing equipment. It has a comparable cost to the UF resins as well as comparable performance to the UF resins. In addition, the Ligate containing products store carbon, helping to mitigate climate change, and Scion is currently in the process of commercialising this product. My last example of a bioproduct that can be made from wood sources is the synthesis of bioplastics. So the bioplastic that I'm going to talk about here is PHA, or Polyhydroxy Alkanoid. This bioplastic is made from the fermentation of sugar, such as the sugars that you can find in the cellulose of the wood. The bacteria store PHA in their cells, just like humans store fat, and this is collected post-fermentation. The photo on the right shows the lab scale equipment that we have to do this. So we have a large 100-litre fermenter where we can ferment the wood sugars, and after about 3 days we can produce about 1 kg of PHA. Once you take the bacteria out of the fermenters, you put them through the cell disruptor that breaks apart the cells, and then we can extract out the PHA via centrifugation. So we have a lot of expertise in making and producing the PHA. It is also a commercially available plastic. And again, this bioplastic can be processed on standard processing, polymer processing equipment such as extruders and injection moulders. The disadvantage of PHA is it's quite expensive compared to conventional plastics, but this is coming down as it becomes more and more widely used in the world. However, on the plus side, it is a plastic that is fully biodegradable. And the most exciting thing about PHA is because it's made via fermentation, it can be made on a smaller scale. That's meaning we can make it here in New Zealand. And there's a company planning to do just this. So at the bottom of the slide there on the left, we have Plentiful. Plentiful is the name of this company. They have just broken ground on a manufacturing site in Martin in the Manawatu. Initially, they plan to use this plant to use dairy industry waste to turn it into the PHA as shown in the diagram there, but the longer term plan is to use other residues such as forestry residues as their feedstock. So this brings me to the end of my presentation. In summary, we cannot continue to use our resources at the rate we are and in the way we are, particularly not using the complete resource. We need to look at the whole item and use every part of it if we expect not to see any impact on our planet. So one way of doing this is to take the materials previously seen as waste from our forest industry and use them as resources for products for a sustainable future. And I've just presented a number of examples of ways that we're doing this at Scion. So finally, I'd just like to say thank you very much for your attention. I hope you've enjoyed the presentation, and if you'd like to get in touch, my contact details are there on the slide. Thank you.